In this video, I'm going to talk about maximum power transfer theorem. So the maximum power transfer theorem is helpful to find out when will be the maximum power transferred through the circuit. So why do you care about the maximum power? Usually we should care about the maximum efficiency, not the maximum power. Okay, efficiency is indicated with eta equal to output power over input power, output over input. So usually whatever input power we are giving, if we get the maximum output, that is maximum efficiency. The maximum efficiency you can get 1 or 100%. If I multiply this with 100, that's 100%. That this is the maximum efficiency. But we're talking about the maximum power, not the maximum efficiency. When will we get the maximum power across the load resistance? Why do you care for that? Say for example, if you take a solar panel, okay, sunlight is free, I don't care about the input. All I care for the output power, how much power I'm getting the output. Okay, so there I need to look for the maximum output power because my input is solar sunlight, which is free. Okay, so those cases this theorem is very useful. So here in this case, I equal to V Thevenin over R Thevenin plus RL. I took a simple circuit where voltage source is V Thevenin, another internal resistance, I'm calling that as R Thevenin, RL is the load resistance. All I care for the power consumed by this resistor. Now power consumed in PL equal to I square times RL. If I substitute I square, which is V Thevenin square divided by V Thevenin square times RL divided by R Thevenin plus RL. This is my load power. Now to find out the maximum power, differentiate this PL with respect to RL and make it equal to 0. So here is the differentiation. I used U by V formula, V times V prime minus U times V prime divided by V square, that's du by dt. So based on this, I end up with R Thevenin equal to RL. So when will be the maximum power transferred through the circuit? When the load resistance is equal to the internal resistance, that's where the maximum power is going to transfer. So this is very important point. So maximum power will be transferred into the circuit when internal resistance is equal to load resistance. So here is an example. All our maximum power transfer theorem examples are going to be similar to this. Now here find the power consumed by the load resistance RL. So definitely RL value will not be given. So in maximum power transfer theorem, RL value will not be given. You need to find that RL value. RL when maximum power is transferring through the circuit. So find Thevenin equivalent circuit and make R Thevenin equal to RL. That will be your load resistance, and you can find the power consumed by that. Step 1, as usual, you can use the Norton theorem or Thevenin theorem. Usually most of the cases will use the Thevenin theorem. So step 1 is similar to Thevenin theorem. Remove the resistor, label the terminals. So I'm going to remove that RL, label the terminals as AB. Now at VA, since there won't be any current passing through this 10 ohms, that can be 0. So at VA, I'm applying KCL. So step 2, find the V Thevenin. V Thevenin equal to VAB, which is VA because VA minus VB equal to VA, because whenever I use the nodal analysis, I'm going to make one node as a ground node. I'm going to make this B as a ground. Now I'm applying KCL at VA. I1 plus I2 plus I3 equal to 0. We know I3 equal to 0 because it's open circuit. I1 equal to VA minus 30. The voltage at this point is 30 volt because this is grounded. That's 0 volt. Minus 2 plus 0. So end up with VA equal to 40 volt. That VA is nothing but V Thevenin because VB equal to 0. I end up with that value as 40 volt. Step 3, find R Thevenin. Similar to the or Thevenin equivalent circuit. How do you find Thevenin equivalent resistance? We will follow the same methodology. Remove all independent sources with their internal resistance. So voltage source, short circuit, current source, open circuit. That's what I did here. And then if there is a dependent source, keep it as it is and connect a 1 ampere source between AB terminals and find for VAB. Then you can find the RAB. So here my RAB is these two resistors are in series. Simple. That's 15 ohm. So step 4, VThevenin equal to, write down VThevenin equivalent circuit, which is VThevenin equal to 40 volt, RThevenin equal to 15 ohm. Now, since he clearly mentioned maximum power is transferring through a circuit, we know that whenever RThevenin equal to RL, then we will see maximum power transferring through a circuit. So I substituted RL equal to 15 ohms. So my I equal to 40 divided by 30, 4 by 3 ampere. Power consumed in the load is 26.53 watt. So this is the maximum power transfer theorem. So as I mentioned, you understand not Thevenin theorem, Norton theorem, and maximum power transfer theorems are nothing. Just follow the Thevenin rules. Okay, I'll stop this video here. Might make more videos based on the Norton theorem and maximum power transfer theorem. Thank you.